And welcome back, students. As we get into our last lesson here on files, we're going to today discuss random access to binary files. Particularly, we're going to focus on reading and writing to the same file. So getting started here, the streams that we've discussed in this chapter for sequential access to files, which we kind of had discussed in previous lessons in this chapters, are the ones that are most often used for file access in Java. So we're going to talk about either text files or binary files. However, some applications that require very rapid access to records in very large databases require some sort of random access to particular parts of a file. Now, typically such applications might best be done with specialized database software, whether it's like Microsoft Access or like MySQL applications, something like that. But perhaps sometimes you're given the job of writing such a package in Java, or perhaps you're just curious about how such things are done in Java. Now, Java does provide for random access files, so your program can both read from and write to random locations within a file. So in this lesson, we're going to describe some simple uses of random access to files. First thing we need to discuss, though, is the file pointer. If you want random access to both read and write to a file in Java, you're going to use the stream class random access file, which is in the Java I/O package like all other I/O classes. Now, a random access file consists of a sequence of bytes. There's a kind of marker which is called the file pointer that is always positioned at one of these bytes. All reads and writes take place starting at the location, therefore the file pointer. Now you can move the file pointer to a new location with the method seek. Now when we're talking about reading and writing to the same file, although a random access file is byte oriented, there are methods to allow for reading or writing values of the primitive types and of string values to that of a random access file. In fact, these are the same methods as those we've already used for sequential access files as previously discussed. A random access file has the methods write in, write double, write UTF, and so forth, as well as the methods read in, read double, read UTF, and so forth. However, the class random access file does not have the methods write object or read object. Now, later on, I'm going to show you the most important methods from the random access file, and I'm going to show you this in a couple slides. But one of the big things to take away here with this is that you'll notice, without having write object and read object, it kind of limits you on what you can do in terms of class type files. So you're kind of more stuck with your more primitive types. Now, a demonstration for random access files is going to be shown here in our random access demo. So before I get into that, let me just kind of quickly show you that here. You can see I have 3 import statements right here. I have random access file, I have IO exception, and found not found exception. So it's right here. It's going to create the random access file IO stream, and it's going to, of course, new random access file byte data RW, writing 3 bytes to the file. It's going to write byte 1, 2, 3, and now it's going to say the length of the file is now this. It's going to list the length. It's going to tell me the location of the file pointer, and then it's going to tell me that it's moving to location 1. Once it's done that, it's going to do the byte. The value of location 1 is 1 byte. Etc. So forth. And it's going to do that all the way down until we get to the technically last one here. You can see here we have write double. And of course, if we have any problems, we can catch up here. Now I'm just going to run this real quick here. Alright. So we have, of course, writing 3 bytes to the file. Alright. So remember 1, 2, 3. The length of the file is now 3. The file pointer location is 3. Then we're going to move the file pointer to location 1, because remember, it's going to be at 3 because it had to write those files first. And so then it resets it to 1. The value of location 1 is 2. Then the value of the next location is 3. Now you might wonder, why is it 2? Remember, you can leave it kind of like an array. So this is at position 0, 1, 2. Okay. Now we move the file pointer back to location 1 and change the byte. So the value of location 1 is now 9. Now if we go to the end of the file and write a double, the length of the file is now 11. So then we go back to location 3 where we wrote the double, and the double at that location value is 41.99. End of program. Alright. So again, it's pretty self-explanatory what it does here. The print line statements help explain that pretty well. But let's just kind of finish going over the processes of how this actually works. So when we're opening a file, the constructor for random access file will take either a string name for the file or an object of the class file as the first argument. And we saw that in the first line of our program. The second argument must be one of the 4 strings, RW, R, and 2 modes we do not discuss in this text, which is RW and RWD. The RW means your code can both read and write to the file if it's open, and R means your code can read from the file but is not written to the file. Now, if the file already exists, therefore when it's open, the length is not reset, therefore it is 0, but the file pointer will be positioned at the start of the file, which is what you typically expect, at least for R. Alright, if the length of the file is not what you want, of course you can exchange it with the method setLength. In particular, you can use setLength also to empty the file. Alright, and if you are familiar with any kind of file permissions, these make sense here. Reading means simply you can access the file. Write means that you can modify the file. Right, so those are just some different modes here. Of course, like I said, RS and RD, I'm not going to discuss that here for this course. All right, now one pitfall to discuss here is that random access file does not need to start empty. So if a file already exists, then when it's opened with random access file, the length is not reset to 0, but the file pointer will be positioned at the start of the file. So old data in the file is now lost, and the file pointer is set for the most likely position for reading, not the most likely position for writing. So it's one thing you have to keep in mind. It's going to be like, hey, I'm at position 0. I can read the file for you, but if you're looking to write, well, you might have to do a little bit of work. All right, so just as keeping this in mind, the last thing to kind of promote is that the class random access file is within our Java IO package. All right, here's those methods that I promised us to look at. Of course, when you make your public access file, it's going to contain a string file name followed by a string mode. All right, you can of course also do a file object string mode. Both of these are of course going to open the file, which does not delete the data already in the file, but does position the file pointer at the first or the 0th location. The mode must be in one of the following: either R, which is for read only, RW, which is for read and write, RWS, which is the same as RW, but also requires that every update of the file's content and metadata be written sequentially to the underlying storage device. RWD, which is again the same as RW, but also requires that every update of the file's content be written sequentially to the underlying storage device. And again, if you remember, RS and RW we're not really going to worry about. So for our purposes, we're only going to stick with R and RW. All right, we also, of course, now we're going to start seeing some things that we are very familiar here. Like, for example, get file pointer. This is simply just returns the current location of the file pointer. And remember, locations are numbers starting at 0, just like with an array. You also have the void seek, which is a long, and that's the location, which is going to throw an IO exception, which simply just moves the file pointer to a specified location. You also have long length, which is going to return the length of the file. And then, of course, you have setLength, which is, of course, going to set the length of the file. Now, if the present length of the file as returned by the length method is greater than the new length argument, then the file will be truncated. In this case, if the file pointer is as returned by the getFilePointer method is greater than the new length, then after this method returns, the file pointer will be equal to new length. If the present length of the file as returned by the length method is smaller than new length, then the file will be extended. In this case, the contents of the extended portion of the file are not defined. And lastly, of course, we have our close, which simply just closes the string connection. All right. Now, of course, these ones are going to kind of speed up a little bit here. We have our write, which just writes the specified byte to the file. And of course, we have a byte array A, which writes a.length bytes from the specified byte array to the file. We have write byte B, of course, writes byte B to the file. Write short writes a short. Write int writes an int. Write long writes a long. Write double, etc. You can see these are pretty self-explanatory in what that they can do. Of course, we have a write double, a write float, write char, and write boolean. We also have a write UTF. And then we have our read ones, which of course are going to pretty much be exactly the same, except they're going to be for the corresponding types. So we have an int read, we have an int read byte array A, we have a byte read byte, we have a final short read short, we have a read int, read long, read double, a read float, read char, read boolean, and read UTF. All these, of course, are just reading the appropriate value from the file, returning it, and throwing the end of file exception if it's attempting to read beyond the end of the file. All right, and that's going to wrap up this lesson for today, folks. So when we come back, the next topic we get to talk about is the infamous recursion. So until then.